Good evening, everybody, and welcome to another episode of vBrownBag. Tonight, we have a special guest, a person near and dear to my heart, somebody that I work with, the amazing, the illustrious, the dapper Sean Hicks. Tonight, he is going to talk to us about VM on X. He's been spending a lot of time doing VMC. We've been having a couple of really good conversations around the old water cooler, which is now virtual. And we're gonna get into some of the cool, fun things that we can do with it. But first, let's do a couple of show notes. Get in on the conversation. If you at vBrownBag or hashtag vBrownBag, I will be paying attention on the Twitter sphere. If you are in the live studio audience, I'll be paying attention there to bubble up your questions to Mr. Hicks. Give us a shout out, say howdy to us. Mr. Sean Hicks is at Sean Hicks 77. I, of course, am Chris Williams, your irritating host, MC, whatever you want to call me. You can find me at Mistfire. So without further ado, Mr. Hicks, are you there?
I am.
Awesome. I am going to stop sharing and hand the power over to you.
Sure thing. Let's share desktop 2. And we will go right into the presentation mode, maybe. All right, so
I can see your presentation. Awesome.
Fantastic. Life is good. It was bad momentarily, so thanks everybody for hanging in there with me. I really appreciate it. But again, my name is Sean Hicks, as Chris mentioned, and today we want to just do a quick introduction. We will level set on the cloud operating model and what exactly is meant by hybrid cloud. Go into a little bit of the state of SDDC and SDI. We'll talk about VMware hybrid cloud, why it's a thing, and then we'll review at a high level some of the different solutions that are out there. And then we will hopefully have time to do a quick operational walkthrough of VMC on AWS. So once again, Sean Hicks, I'm a technical solutions architect covering hybrid cloud platforms for worldwide technology.
And Nerf aficionado?
I am. I reside in Dallas, Texas, attended Southern Methodist University and just never left. Had plenty of opportunities, but for some reason, this is home. So was with Cisco Systems for 11 years as an engineer, then went to Firefly. Was a technical instructor teaching some of the early converged stuff around UCS and MDS and Nexus switches and of course VMware as well. I then worked at a smaller reseller and managed their data center practice for most of my time with them, and have been at Worldwide now for about 2.5 years. So as Chris pointed out, I do hunt pretend zombies for fun with highly modified Nerf blasters. It's good fun. No pretend zombies are hurt, at least as long as they wear their eye protection. And I was hit by a truck at the age of 12 as I was riding my bike home from school. So now you all know exactly what is wrong with me, and everything I say from this point on can be traced back to that moment in time. I actually owned a couple businesses. I co-owned a record label with some musician friends of mine. Very briefly, I think we had like 1.5 releases. And I also co-owned another business with some friends making color-changing wine labels that changed colors whenever the wine inside the bottle reached the correct serving temperature for that particular type of wine. And you can't see me on video right now, but I am growing, and Chris will tell you because he's seen me on video recently, I am growing a magnificent quarantine beard. My wife calls it the Brillo pad, and my pants have never been cleaner. All good. So I told you we're going to level set. Let's do that real fast. I have been in rooms where grown adults got into screaming matches about what was meant by cloud. And we think we've all heard the cliche thing that if you ask 10 people what cloud is, you'll get 10 different answers. Well, the reality is that there is published definition cloud computing. And so it goes on to define just some essential characteristics. So all the things that we love about cloud, we love the ability to get what we need without having to open tickets with anybody or waiting for weeks on end to get our resources. We love that we can access it from just about anywhere on the planet using all kinds of different devices. We love the ability to pull off resources and say, these are mine. And we love the elasticity to grow those resources or shrink them on demand. And of course, the ability to do on-demand billing as well, right? So we love that sort of OpEx model of, instead of the old build it and they will come approach to building IT infrastructure. Few deployment models that are defined in the standard and service models defined, but the thing that I want to focus on for this conversation is the following. So this is directly from the document, and hybrid cloud is when you have two or more cloud environments and they remain completely unique entities. That is that they don't necessarily coalesce with one another. They are separate infrastructures, but there is some kind of technology overlaying them that allows application and data portability between those infrastructures. And so let's keep that in the backs of our minds as we go into the rest of this presentation. So beginning with, as you may have noticed on the previous slide, cloud is an operating model. It's not really a destination. Often when we say cloud, we think of AWS, or we think of Azure, or we think of a private cloud. And really, it's about how it operates. You saw those essential characteristics. And all of those essential characteristics, we'll just go back to that real quick, just to remind everybody. All of those essential characteristics of what makes it cloud computing happen up here in these white layers. So within your own environment, you might have ServiceNow. You might be using vRealize Automation as a cloud management platform. And you might be using things like Ansible and Terraform to do infrastructure as code or something along those lines. And you probably have a CI/CD pipeline, or at least you hope to get to this state. But remember the definition of hybrid cloud. Keep that in mind, because that really happens down here in the green boxes, which is software-defined infrastructure. And when we look at the various providers out there, we see that they all pretty much offer very similar services for software-defined infrastructure. If we look at AWS, you have compute service, Elastic Compute. You have a storage service. Actually, you have multiple storage services, depending on if you want to do block, S3, or file. And you have an entity that encapsulates lots of networking and security services, network security services, in the form of the virtual private cloud, the VPC. And then, of course, you've got your operational tools for managing and monitoring the environment. And if we look at other cloud providers, we see that same format. It's not an accident that they all sort of fell into this mold. If we look back at the early OpenStack environments, we can kind of see the lineage of where these things came from. So once again, with Azure, you've got Azure Virtual Machines, you've got Azure Disk or other types of storage services such as Blob. You've got the virtual network or VNet, and you've got Azure Resource Manager and Azure Monitor. Google Cloud, no surprise, same format. You have Compute Engine, you have Kubernetes Engine, or sorry, Container Engine. The K stands for containers. You have different storage services. You have what they call a VPC network, which is the equivalent of the other encapsulations of various network and network security services. And of course, you have your management operation tools. And hopefully everybody that's in the audience today is familiar with VMware Cloud Foundation, which is exactly VMware's attempt to bring this exact model to private infrastructure or private cloud. So, you have your compute, which is now provided by vSphere, whether that's a virtual machine or a container, by the way, in VCF 4.0. You have vSAN, which started off as offering up disk images for, or VMDKs, I should say, for virtual machines, but is now starting to offer file services as well. And I understand in the roadmap, potentially one day object. We have NSX, which encapsulates lots of networking services and network security. And then, of course, we have our operations and management tools as well in the vRealize suite. So I told you to keep in mind the definition of hybrid cloud. The problem that we run into here is that the vSphere hypervisor is not compatible with AWS's hypervisor. You cannot just take a virtual machine off of your VCF environment and drop it into your AWS environment, at least not without additional tooling to do that translation. And so this is something that often slows down migrations because we're replatforming. Re-architecting obviously takes a long time. So a lot of the times what we really want to do is just take applications that we already have and drop them into somebody else's data center. And so that's what we propose here is, what if we could do something like this? What if we could be in AWS or Azure or Google Cloud or a number of other cloud provider partners that VMware has, and have that compatibility for our VMware-based applications to be able to move virtual machines, to be able to replicate data, and even to have the same network and security tools across the board. And so with that, I propose that we put VMware on everything. And if you don't know, I love to cook. I come from a family where the men traditionally do the cooking, actually. So that is my apron. But if we take a look at VMware Hybrid Cloud, we start with VCF or on-prem, and then we have some options for fully managed, whether it's managed by VMware or managed by a VMware cloud provider partner, VMware solutions that sit on infrastructure that, in the case of VMC on Dell, sits on-prem, but it's not our infrastructure. We don't manage it. It's lifecycle managed by VMware. In case of AWS, similarly, the VMware components are lifecycle managed by VMware, and the underlying infrastructure is AWS Nitro, managed by AWS. And then a little history lesson here, in case you're not aware, there was a VMware cloud provider partner named CloudSimple. They partnered with Azure to build the Azure VMware solution. Not long after that, they also partnered with Google Cloud to start building what GA'd at the end of June. So it's only, it's fresh, it's only 3 weeks old now, Google Cloud VMware Engine. And then in November of last year, Google bought CloudSimple. So they have rebranded everything from being CloudSimple to being Google Cloud and VMware Engine. We're actually, at WWT, we're lucky enough to be a launch partner for this, so we've actually had access to this for a little while now. But Google folded this into their cloud console, so it's actually listed among the compute services that you can spin up a Google Cloud VMware Engine private cloud. And Microsoft, for their part, is also rebranding and taking all support in-house because Google bought the original partner, CloudSimple. So just a quick note, because it came up recently for discussion, you can still buy Azure VMware solution, but you need to purchase additional support credits or support quota in the region where you hope to deploy it. In the meantime, Azure is bringing this solution completely in-house, making it a single party solution, and the new Microsoft version of it should be GA'd in sometime in November, is what I'm told by my sources. But anyway, and then VMC on AWS, that's like I said, VMware and AWS managed. It's the granddaddy. It's the one that's been around the longest and been through several revisions to this point. In fact, we just celebrated the release of M11 recently, and I'll talk about a few of the cool features that came in M11 as we get into the VMC on AWS overview. So why do you want to do this? Well, there's a few use cases that we at Worldwide have sort of built some buckets around, and we really distilled it down to these 4 buckets. So on the left-hand side, starting there, data center evacuation. You have those organizations that want to switch from a CapEx model to an OpEx model for acquiring their IT infrastructure. you have organizations that have a get to the cloud however you can, as fast as you can mentality. But again, with the replatforming or re-architecting, it's a problem. So if I could lift and shift just VMware VMs, I could probably accelerate that migration. And then you also have a lot of organizations that they don't really see a lot of value in the day-to-day operations of a data center. If you think about things that we've all in IT kept ourselves busy with at some point or another, like crawling around on the floor with the dust bunnies to run cables in the under the raised floor tiles, or breaking out the drill or bringing your drill from home to rack equipment in the cabinet, or even beyond that. If you think about things like physical data center security, man traps, cameras, lighting, fencing, or dual redundant power feeds from reliable sources, or building data halls that have different power feeds, different network feeds, and everything else. There's a lot that goes into running a data center that isn't really the core business of the company in question. And frankly, unless they are a Microsoft or an AWS, they're not going to do data center better than the cloud providers. So another one is what we call hybrid cloud extension, which we've all heard the burst of the cloud thing. I won't spend any time on that. But one thing that was really interesting recently with the coronavirus, the novel coronavirus and the ensuing pandemic, is that the world suddenly had a massive influx in remote workers. And suddenly, with international logistics being disrupted by different countries closing and ports closing and everything, it became really difficult to get additional IT infrastructure for servicing all these new remote workers. And so we were seeing a rush in people wanting to deploy things like VMC on AWS so that they could extend their Horizon solutions or their Workspace ONE solutions on top of it to accommodate all the people that were going to be working from home. And because it was on demand and it was in the cloud, they could get it versus sitting around waiting for their favorite server vendor to get something over the Pacific Ocean to them. Not only that, but some of them do anticipate that at some point in the future, those remote employees may return to an office. And so they didn't want to invest in permanent infrastructure to support those cases. So yeah, we saw a lot of interest there. Disaster recovery, typically we sort of refer to it as disaster recovery as a service. And the idea there is it's the old story of why would I build an entirely separate data center that sits around unused most of the time, waiting for the other one to blow up? What if I could have just a minimum set of gear that's operational, and then I could expand that automatically whenever the need arises? And so that's something we can do, and we can do it with tools that we already have and love, like, for instance, VMware Site Recovery Manager, or Data Domain. We can run Data Domain Cloud Edition to be able to back up our virtual machines, which, by the way, none of these solutions does the cloud provider or VMware take responsibility for backing up your workloads. So that is still incumbent upon you, the customer, the consumer of these services, to do that. So plan accordingly. And then once again, just the fact that these cloud providers are very good at running data centers, so their environments typically see a very high number of nines in terms of availability. And application modernization it could be anything as simple as just getting workloads closer to each other. You may have a multi-tiered application stack with certain elements of it that are sitting as VMware virtual machines. Certain elements of it are cloud native services like AWS Lambda functions, or RDS database, or maybe it's a container that you're running in the cloud, like an EKS or GKE. And you just need that VMware-based workload to be closer to the rest of the application suite for the purposes of a better user experience through lower network latency and better application performance. In the case of all the newly remote workers in the world, getting VDI services closer to them. Cloud providers are typically closer to those users in terms of network hops than is your data center. And sometimes we just want a runway. We just want a parking place, if you will, to hold those applications that we do intend to refactor or re-architect. And so that's another valid use case that we've seen. At this point, I'm going to take a quick pause and see if we have any questions in the chat yet.
We've got some snarky comments from our regulars. So we do have a lot of attendees that are very steeped in VMware. vBrownBag originally cut its teeth in like the VMware ecosphere. So yes, no questions as of yet. But I do have some of my regular smartasses in here.
I will ask that you screen capture these snarky comments for my own entertainment later.
Oh, I absolutely will. I will share right as soon as we're finished.
All right. So high-level overview of VMC on AWS. This is, like I said, the granddaddy of the solutions. It's been around for a little while now, and we did just celebrate another release in the M11 release. And it is what it sounds like. It is AWS bare metal instances running ESXi, running vSAN, running NSXT. You do not have to have NSXT on-prem, but you get it whether you like it or not in VMC on AWS. And there's a few different ways to connect to it. Typically, all of these solutions will support point-to-site VPN, site-to-site VPN, and then each one has their version of what AWS calls Direct Connect, which is our preferred way, and the way that we have it set up in our lab environment. And then kind of unique to VMC on AWS is that they take advantage of what AWS calls an elastic network interface to put an interface of your NSXT0 router into, whoops, Apple Magic Mouse, people. To put an interface into one VPC that is owned by you, the customer, the consumer. And so that allows you immediate access to AWS services in that VPC. So you could do things over here like throw up an S3 instance to save off data as like a secondary storage from your virtual machines over here. You could do things like deploy an elastic load balancer, and there's a lot of caveats to keep in mind, but you could potentially have a traffic flow that comes in this way and then comes in over here across the ENI. I want to go back actually because I'm not done. We did, like I said, in the new M11 release, we got some new things here that are nice because believe it or not, I don't know if everybody on the call is familiar with Transit Gateway, but in AWS, the VPC gateway, the virtual private gateway, is not capable of holding a whole lot of routes. And so it's pretty limited in terms of how many VPCs you can actually peer with one another. And so for a long time, we were building what we called transit VPCs. And then through the magic of network function virtualization, we were running virtual routers like Cisco CSR 1000Vs in those transit VPCs because they could support a lot more routes. And then we could build out much larger infrastructures within AWS. And so we might have like a transit VPC in each region that we're operating in. So AWS came out with Transit Gateway, and it's something you deploy in a region, and it allows you to route to many more VPCs than the virtual private gateways support. You can connect your VMC on AWS VPC. It's not technically your VPC, it's technically VMware's VPC. You can connect it to a transit gateway using a VPN connection. Worth noting, that is not supported by VMware for on-prem connectivity. Does it work? Yes, it does. Is it supported? No, it is not. You can use it to connect to a whole bunch of other VPCs in AWS, but it is not supported for on-prem connectivity. And with the M11 release, we got a new feature. We got Transit Connect, which is VMware's managed version of Transit Gateway. And that enables me to have lots of VMC on AWS SDDCs and different VPCs all connected to each other across Transit Connect, as well as being able to route to a number of native VPCs across Transit Connect, and the ability to connect on-prem using Transit Connect as well. Interesting note there that you want to pay attention to. Man, this magic mouse is not behaving today. Interesting note that you want to pay attention to there is the Transit Connect feature will not allow you to route from a native VPC to another native VPC in your AWS organization. That still needs to go through a traditional Transit Gateway or Transit VPC or whatever you have set up for that.
Interesting. Quick question from the
yep.
audience.
Sure.
This goes back a little, just a couple of minutes. So the VPC comes with cloud whether you want it or not as well. So the VPC that doesn't encapsulate the VMC.
The native VPC, yes. So if you spin up a VMC on AWS instance, you need at a bare minimum one native AWS VPC. It will actually ask for that whenever you go to deploy your SDDC for the first time.
Right. Okay. And follow-up question to that: you had indicated that it was unique to VMC, and you might be getting into this later on in the talk. And if you are, then just talk.
The Elastic Network Interface connection seems to be unique to VMC, at least in as much as I've seen. I will preface that by saying I do not have experience with VMware on the IBM cloud, nor do I have experience with VMware on Alibaba cloud. However, from what I've seen in VMC on AWS, in Azure VMware Solution, and in GCVE, Google Cloud VMware Engine, that E&I interface seems to be unique to VMC on AWS. And one caveat of that, by the way, as your T0 router from NSX floats between the cluster members of your original cluster in your SDDC, do note that the bandwidth limitation for that Elastic Network Interface is exactly the physical NIC connectivity of whichever host in the cluster is currently hosting the active T0 instance.
Thank you.
So the other things that we got in M11 that are interesting, we got a vSAN improvement. Our slack space requirement has gone from 25 to 20. That's important because we have Elastic DRS in VMC on AWS, and whenever vSAN slack space can no longer be satisfied, it will automatically expand the cluster. Want to keep an eye on that for spin purposes, but also at M11, we got the ability to have two-node clusters. Originally, you had to have at least 3 for it to be production. You have had the ability for some time now to spin up a single node instance, but that is not a production instance. That is only meant for customers to do proof of concept. But you can do a 2-node cluster now, starting with M11. However, I will warn everybody what I just said about EDRS and vSAN slack space. If you cannot satisfy your vSAN slack space, it will automatically expand to 3 nodes. And keep in mind, for any customer that wants to run a 2-node SDDC, once you go from 2 to 3, you cannot go back to 2. Just the way it is today. Another caveat that we spend a lot of time on with customers is, even though you have NSXT over here, there is no federation. If they have an SXT on the private data center, there is no federation yet to unify the management of policies. And also, the NSXT instance in VMC on AWS does not currently allow you to take advantage of any kind of load balancing. So you will need to plan for deploying one-armed load balancers in your network segments. Maybe you're using AVI standalone one-armed load balancers. That would be fine. So I've spoken at some length about this one. I'll get into Azure VMware solution. Again, this was originally built for Azure by Cloud Simple. Microsoft is taking it all back in-house. It is similar in that you consume some Azure bare metal instances. They automatically deploy the VMware components on top of them for you. And then that sits off in a VNet that's not really your VNet. But those services and those bare metal instances are available to you. Uses, again, point-to-site VPN or point-to-point VPN or express route for the on-prem connectivity. Interestingly, with Azure VMware solution, to connect to native VNets, you would use express route global reach, which allows you to share by the magic of BGP and Microsoft Azure's global backbone, share your routes across all these different VNets and then back into the what we used to call the Cloud Simple environment. But anyways, you can run your private cloud over here and similar use cases. I can have direct connectivity to Azure services. I can have the ability to put virtual machines from on-prem closer to those Azure services and anything else I have to be running in Azure. And again, just so everybody knows, you can still get this. You need to contact your Azure people and get additional support quota in the region you want to deploy it. Or you could wait till November whenever they go live with the completely Microsoft branded version of it. I'm going to pause there. We had some questions about VMC on AWS. I want to make sure if there's any questions about this one in particular that we get to them.
And double checking the feeds. No, that's good.
Okay.
Nope, we're good. Yes, no, we're good.
All right. So Google Cloud VMware Engine. This one is actually very similar because it was also built by Cloud Simple, which is now owned by Google Cloud. Again, same VPN options. You can do a dedicated interconnect or partner interconnect for direct connectivity between on-prem and your Google Cloud private cloud. Somewhat unique to Google Cloud is when you spin up this service, actually for all three of these, when you spin up this service, you're going to be on the hook for providing them with some CIDRs, some network subnets to use for addressing the various components. They'll ask, in the case of Azure VMware Solution and Google Cloud, they'll ask for a vSphere vSAN subnet, which is actually an infrastructure subnet, and depending on whether you give them a /22 or a /23 or a /24, they're going to carve that variable length subnet masking into different sections to handle everything from vCenter and ESXi management, vSAN, vMotion, NSX host transport, NSX edge services, as well as your NSX edge gateway VLANs. So all concepts that if you've been in any VCF environment, you should be familiar with. They're kind of the bare minimum networking for VCF in terms of service VLANs. So it will do all of that, but then you might want to connect to a Google Cloud native service, and you might want to do that using a private IP address, so from a subnet that your network recognizes, so that it doesn't go across the public internet. And so Google has what they call a shared VPC network that is shared between the end user, the consumer of the service, as well as Google Cloud, and that allows you to do that private IP addressing using your IP addresses of interfaces to Google Cloud native services. So kind of an interesting aspect to that one. And I'll pause once again to see if there are specific questions about Google Cloud VMware Engine.
A couple of comments about this is good stuff, but no specific questions.
Okay. Again, Google Cloud VMware Engine is 3 weeks since GA. It went GA at the end of June. So it's out there in the wild and available. And by the way, both of these solutions, both Azure VMware solution as well as Google Cloud VMware Engine, one thing Cloud Simple did a great job of, I think, is in their documentation. So if you care to go look at it, both of those solutions have their documentation published on the cloud provider sites, and they did a really good job of laying out the concepts and what you need to do to get started, as well as how you interconnect both on-prem and to native services. I won't go into a lot of detail about hybrid cloud extension because I believe you guys did a vBrownBag on that just back in May in depth. So in fact, I think I did watch that one and it was very good. But HCX is the tool for bulk migrating or live vMotioning your virtual machines between on-prem and these services. And HCX, as many of you are aware, actually has more in common with NSX than it does with any kind of migration tool. And you know what it does is it deploys the fleet appliances. You get the interconnect, you get the layer 2 extension, you get the WAN optimization, which is really a Silver Peak virtual machine, is my understanding. And then you can begin moving stuff across. Now there are caveats here to these cloud services that I do want to point out in relation to HCX. That do not require me to go into detail about HCX itself. Again, go back and watch the previous vBrownBag. But keep in mind that in order to support vMotion, there is a minimum 100 megabit connection requirement between on-prem and the cloud. So in fact, for our lab here at Worldwide, we do have a 100 megabit direct connect link between our lab and VMC on AWS for that specific purpose. HCX does not work across VPN. Makes sense because it's essentially building a VPN connection itself, so you don't want to do tunnel and tunnel. The way it works is if you have, like say in VMC on AWS, if you have direct connect, HCX will prefer the direct connect link. That's what it will use. If you do not have direct connect, it has the ability to build those tunnels over the public internet, and will prefer that method. Jumbo framing may come into consideration as well. If that's the case, you probably don't want to go across the public internet. You probably want to have direct connect if you need to support jumbo frames here. Any questions about HCX in particular?
Not that they couldn't watch the other video on, if I'm getting your read correctly.
Very important thing to note on HCX is that in VMC on AWS, HCX licensing is included. You do not need to purchase additional HCX licensing when you are a VMC on AWS customer. And that's going to bring us to the end of this portion. I do want to take a moment to kind of walk you guys through our VMC on AWS environment and show you sort of operationally, maybe point out a few gotchas. I will be doing this from a Horizon desktop client, which is not the fastest. That's on our infrastructure. That's not on Horizon, by the way. But as soon as Google Chrome loads here, we will take a quick tour.
While that's spinning up, a quick question from the audience. So can you vMotion between clouds?
With HCX, yes, you can.
And is that hot vMotion, or do you have to spin the VM down?
So live vMotion, again, we want to start talking about jumbo framing, whether or not we support that, and also the bandwidth connection. The bandwidth of our connectivity, end to end becomes a factor in whether or not you can do that.
Gotcha. Thank you.
So my highly organized. I may go into this second. Actually, I think first I'll just show you guys that it's literally just a VMware environment. There's really nothing special about it. Everybody's got their key loggers out.
Absolutely.
And I might actually log out and log back in as cloud admin because there will be a few other things I want you to see, because right now I'm logged in with my SSO credentials. But if we go in here and look at, oh, I forgot we have hybrid linked mode set up here. So this is a real treat. Everybody gets to see hybrid linked mode, which is our vCenter in VMC on AWS is actually linked back to our VCF environment back at the ATC. So here is our VCF management domain, which is made up of 4 nodes. Pay no attention to those error messages. I'm sure everything is fine. And then our workload domain, which is also made up of 4 nodes here. But this is our VMC on AWS SDDC down here. You can see that it is a 3-node cluster. Pay no attention to this 4th node down here. That is actually deployed by HCX. It is a nested vSphere node for the purposes of facilitating vMotion capabilities. If we select one of these nodes, we can see that it is indeed Amazon EC2 i3 bare metal. We can see some characteristics about this. I think you can just go on AWS's website and read all about i3 metal instances and what they consist of. But this is great because it gives us the ability to go in and look at our vSAN environment as well. So we can see our vSAN data store. One thing to note is because this is our first cluster in this SDDC, it does house all the management components. There is a vCenter, there is an NSXT management cluster, our HCX fleet appliances as well, and some basic vRealize stuff. I believe we have Verly and Verni also out there. All of that is living on the same nodes. If we spin up a second cluster, we do not need to replicate all those things. They can exist solely on the first cluster. If we spin up a second SDDC in this region, then yes, we will get all new management infrastructure. But just know that all that stuff is also out here consuming disk space along with our Horizon on VMC on AWS environment and the few test workloads that we're running. But you can see that we have a total of about 31 terabytes between those 3 nodes. Do know that the default vSAN, the default vSAN policy here is RTT equals 1 until we go past 4 nodes. Then it will go to RTT equals 2 and RAID 1. Worth noting, by the way, you can do a stretched cluster where by part of your cluster lives in one availability zone and region, and the other part of your cluster lives in another availability zone by region. This is really great for workloads that require extremely high availability. Do keep in mind, though, that same rules apply. These nodes have to be like, and it's RAID 1 mirror over to the other availability zone, so those nodes have to also mirror. Meaning that if you spin up 4 nodes in AZ1 and you decide to do stretch cluster, you will also get 4 nodes in AZ2. So you would have 8 nodes total at that point. Also keep in mind, stretch cluster can only be determined at the time you spin up the cluster. You cannot make that decision later. So please know that for planning purposes. And then if we go look at NSX, we will see a bunch of NSX networks in here as well. Like I said, nothing really special. It's a vSphere environment. All the specialness is actually here in how we actually interact with it from a management perspective when we're not doing virtual machines. So not sure. Oh, this is going to be a problem. Hang on, guys. Actually, you know what? It will be easier if I just do this not from Horizon. But this is the stuff that I really want to show you guys. So give me one moment. I'm going to
While,
close
while you're
that.
doing that, Senethil, I see that you've raised your hand in the audience, but if you want to ask a question, just put it in either the chat channel or the Q&A panel, and I'll get that to Sean.
So here we are in the VMware Cloud Services console. And this is where you would go to create an SDDC, to create clusters, to expand clusters, and also to manage NSX. And one thing that I always point out to people is, if you didn't see, I logged into this with my myvmware.com credentials. That is how you log into the Cloud Services console. What that means for you is there is no SSO for the Cloud Services console. Everyone who needs access to this must be entered in the active users using their myvmware.com account name. So essentially what would happen is I would invite you to join the organization, which is up here, WWDC demo. You would accept that, and then you'd come in and I could assign you, let's go mess with John, he's fun. And then I can assign you roles and privileges within the Cloud Services console. So we can see Mr. John here, who is one of our AWS platform architects. We see that he has 2 roles for VMC on AWS. He is an administrator and he is an NSX Cloud admin. We have played with this extensively. So not only do we not have real SSO, but I want to make sure everybody's aware this looks like role-based access control, and it kind of is, but it doesn't really do anything. You can either be a full administrator or an administrator except without the ability to delete clusters and SDDCs. But we've tried this with some test accounts. If we create you as an NSX Cloud auditor, we thought, man, sure, wouldn't it be nice if we could just give somebody an account where they could go in and look at NSX settings. This does nothing. If I take an account and assign it to the NSX Cloud Auditor role, and you log in with that account, you literally get a blank, it'll log in, but you literally get a blank screen. So just be aware. I've talked to my VMware resources, and they told me that if you need to be in here, you're probably an admin, and it's pretty low priority for them to take care of that, which is unfortunate for us since we run a lab. Billing and subscriptions, so we can see here, basically you buy SPP credits, you use them to buy your VMC on AWS instance. By the way, there's 3 ways to buy. You can buy on demand, which costs a certain amount of money per hour. Check with the AWS website for current rates. You can buy on a 1-year commitment, which gives you a significant discount, and you can buy on a 3-year commitment, which gives you an even bigger discount. Let's go back to our services. We're going to log in to VMware Cloud on AWS, well, to the Cloud Services console for VMC on AWS. And you can see here my SDDC. You can see that it's a 3-node cluster. You can see how many cores it has and all the fun performance stats if we select that. By the way, actions up here, I can add clusters to the SDDC. I can add hosts to clusters. I can remove hosts from clusters. And then I can modify the SDDC. Danger zone, by the way, here, don't click on that. And what I really wanted to show you guys is the network and security stuff, because all the NSX management is done from here. And it takes a moment to load every time. I don't know why, but this screen always draws very slow. And you get this nice, pretty diagram over here. For those of you familiar with the whole T0, T1 concept in NSX, what I want you to know is that this big white box is T0, and these routers inside the white box are the T1s. So T0 has logical interfaces. There's one connected to an AWS Internet Gateway. There's multiple connections available for VPN. Do note that VPN links max out at somewhere between 1 and 2 megabits a second. You can bundle VPN links. So like if you were going to connect to a transit gateway, again, not supported for on-prem connectivity, use Transit Connect instead in M11. But You can bundle VPN links in sort of a link aggregation type scenario, but once you go past, I think it's up to 8, but once you go past 4, it's really kind of law of diminishing returns. Not worth it. You can see that we have a direct connect connection, which is actually how we are connected. It is popular to do direct connect for your primary connectivity and a VPN between on-prem and here as a backup connection. VPNs as site-to-site can exist in 2 formats. There are policy-based VPNs and route-based VPNs, and I think they're named backwards. Policy-based VPNs actually use static routing, and route-based VPNs use BGP exchange. So immediately, by the way, you should think that my gateway over here probably needs to support BGP. So if that gateway happens to be a firewall, make sure your firewall runs, has that ability to share BGP, especially if you're doing it across VPN. Then down here, this is the ENI. This is the elastic network interface we talked about. You can see that it is connected to our VPC. That is a native VPC that belongs to us in AWS. T1 for workloads has segments coming off of it for, you guessed it, workloads. I'll show you where you configure those. And the management gateway has segments coming off of it for all the things that we don't actually get to touch. So your vCenter, NSXT, management cluster, all those things that VMware manages on your behalf sit behind the management gateway. By the way, you can do firewall rules, and I'll show you where to do that. When you apply east-west firewall rules like you would for distributed firewall, they are applied at the compute gateway, at this T1 here. When you apply north-south firewall rules, for instance, if you wanted to open up SSH connectivity to vCenter, which you can do if you want to do that, there is a public IP for your vCenter. Those firewall rules are actually applied at the T0. So if we go into network segments, we can see all the segments here. If we wanted to add a segment just to show you guys what kind of information you have to give it, you name it. You tell it whether or not it's routed or not routed. If it needs its own VPN, you can give it a tunnel ID there. You give it a CIDR. You can enable DHCP and then give it a DHCP range, which means DHCP will be served from the T1 gateway. However, we are actually doing DHCP relay, and I'll show you where to configure that. So for those network segments down here that require DHCP, such as our Horizon desktops, that's actually being DHCP relayed across our direct connect link to an InfoBlocks grid that is stretched between our Equinix environment and the ATC back in St. Louis. Oops. So we can create VPNs here. I want to get into the firewall stuff because I know where I'm going a little long here. We got a late start, but again, compute gateway, this is where we set up all of our firewall rules, and it looks just like we're setting up firewall rules in NSX because that's essentially what we're doing. You can, by the way, create security groups. You'll notice that this is a security group, this is a security group. So that's a nice thing to be able to use that feature here. And then if we go to the management gateway, this is where you would create sort of those north-south connections, just do things like open up connectivity to vCenter. So you can see here, vCenter inbound, this security group, or sorry, this group here is all of our RFC 1918 addresses, because everything in the lab should be coming from a 10 dot or a 172 dot address. And so we can filter on that and say, okay, if it's coming from those addresses, it has to be coming from our direct connect back to the lab. It should be okay traffic. They can hit vCenter on these ports. And just to show you where those groups are configured, you can see here, for instance, that RFC 1918 group is right there. And we can view the members just to show you that I'm not lying. And you can see the CIDR blocks for all the RFC 1918 addresses there. Down here is the really cool stuff. We have the ability to do some interesting things with DNS. So right now we are forwarding all DNS to our DNS server instead of using the native DNS in VMC on AWS. You do not have to have an on-prem connection, by the way. As I mentioned earlier, one of the use cases is data center evac. If you're trying to get out of the data center business, you can have an SDDC and evacuate your on-prem data center and just have the SDDC. That would actually be a use case where you do need to open up SSH connectivity to vCenter. However, you do have to have that native native AWS presence in conjunction with, as we mentioned earlier. This is where we set up the DHCP relay. You can see there, we set up give it a DHCP relay address. And so now all of our DHCP requests are being forwarded over to our Infoblox grid. We can look at our direct connect. And here's that ability to enable VPN as a backup to direct connect. We have not done that because our firewall does not support BGP. Here is our local BGP autonomous system. And down here, interestingly, you can see all of the networks that we have created in VMC on AWS are being advertised back to the ATC, and we are learning all of these networks from the ATC. Here is another thing I want to mention. You want to supernet if possible, because the advertised BGP routes, I believe, were limited to advertising 16 routes, not including the routes to the management infrastructure. So let's count them, make sure I'm not in violation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 on the dot, and some of those are for management, so we are safe. And then the connected VPC, like I said before, that elastic network interface is connected to our VPC, and here we can see data about that. And I think that's all we want to take a look at today.
Wonderful.
Any questions from the audience?
So, one moment, please. No, there are comments saying really appreciate it. Good stuff. Great job. But no actual questions. So that means one of two things. They either all fell asleep, or you were so thorough in your presentation that you covered everything that they could have possibly thought about. I'm going to go with the latter. That was very well done. I will. Oops. Actually, I want to do that here. I will show one last parting gift for everyone. I'm going to log out of my SSO credentials here, which will take just a moment. And I'm going to log back in as the default cloud admin. Those of you who are following along, oops, that's wrong. That is so wrong. vmc.local. Those of you who are following along may have seen me open up the vCenter credentials from the Cloud Services console and copy to clipboard the password for the cloud admin account. This is your ultimate admin account. You do not have full control of the environment because, again, VMware Lifecycle manages a lot of the stuff for you. But just to show what we're talking about here, let's go into hosts and clusters. And we're going to see some things that we didn't see before. First of all, you notice the hybrid linked mode is gone. We don't see our on-prem environment anymore. Mm-hmm. But now we see a management resource pool. And when we open it up, we can see HCX Cloud Manager, our NSX edges, our NSX management cluster. These are HCX Fleet appliances. That is our SRM instance. We have vCenter. And all of this is deployed to this management resource pool, which, by the way, I have no ability to do anything with because, again, right, the administrative capabilities are locked up with the VMware Managed Services people who manage this environment on our behalf. So just to show you guys that I'm not lying, and we can even go look at the vSAN data store that wasn't there before that belongs to them.
which is essentially the same vSAN data store, but I can't do anything with it.
Mm.
And there will be some new networks in here that I also cannot mess with because they are being used for management, for NSX, and so on and so forth.
Mm-hmm.
So vMotion, vSAN. So only see this stuff when you're logged in with the cloud admin account. When you log in with SSO, even if you gave yourself cloud admin privileges, you will not see any of the hidden management stuff in the environment.
Secret
And and now I really have nothing else to show you guys.
That was fantastic, Sean. Thank you very much. Let me quickly browse through all of the stuff. I know that we're running late, so let me just quickly scan through here. No, still awake, but no more snark. Sorry. Oh, that's okay, Graham. You're always here for us.
Exhausted
Cool.
the snark.
Oh, we burned him out. Cool. Sean Hicks, thank you very much for coming in tonight and showing us VMC on X. That was very informative. I really enjoyed seeing how everything got tied together across the 3 different systems. Learned a little bit about Azure and GCP, which I didn't know. So kudos to you, sir. Thank you very much.
Oh, thank you, Chris.
All right. Thanks, everybody, and we'll see you again next week.